Again, welcome everybody on your Friday. Thank you for tuning in to this webinar, this introduction to SimCLIM 4.0 for desktop and RCM and GCM data. I know there's a lot of interest out there in this RCM and GCM data. We're going to go through what we have prepared for all of you out there that are interested in doing climate risk assessments and adaptation planning and so on. Let's go back here to a couple of things that I have set up within Acrobat. First of all, just so you know, we do have a very comprehensive data manual, and this is readily available on our website, or we could send this out to you. So it goes through all the background information about how we actually process all the data, all the GCMs and their descriptions, and the sea level rise generator methodologies, Cordex, dynamically downscaled data, precipitation patterns, and so on. So we do have comprehensive documentation for everybody. We also have a very comprehensive manual for SimCLIM 4.0 for desktop essentials here, 206 pages in length. It goes into great detail on all the aspects of running the SimCLIM system. Tonight, we're not going to dive into these activities on an individual basis. You'll see there are lots of icons and lots of different things we could do. I just want to introduce you tonight to the opportunities for using RCM and GCM data. So you see this is all very well laid out here on printing and using the pattern viewer and data managers and browsers. I will introduce you to these things in the program momentarily, and impact models, degree day, PET, water tank, SWOT, and so on. So all of this is detailed in the manual. Now, the other thing, I'll just quickly go back to the program now. Back to SimCLIM. All right, and back to the SimCLIM. I have two opens just to save ourselves some time. I'm going to run you through the toolbar and introduce you to the ideas here, and I will go back and show you another PDF file in a moment. First of all, there's global projections here. So with this global projections, it's sometimes quite handy just to have a look at sea level rise, total CO2 concentrations around the world, and this is all based on IPCC science. So that's what we use at CLIM Systems. We're always working back to that science. This is quite important for standards and such. We like to stay in unison with what's going on with the IPCC. For instance, recently I heard about some declines in wheat yields with changes in CO2, and they said with 550 ppm of CO2, we're looking at a 10% loss of wheat yields. So I wanted to figure out when that was going to be, so I could easily go through, if it's an RCP 8.5, and find out when are we expected to reach about 550 parts per million, and that's around 2050. So this database can be quite handy when you're doing various pieces of work. And it also has a relation to temperature and to sea level rise as a database. This is global data here. You'll see there's very local data within the system itself. Underlying all of this is a scenario generator. This is what I have open here. There's just one map, and I'm going to close that and open up another window for you. And this is quite important to see all of the GCMs and RCMs that are available here. So with this scenario generator, this is the baselines here, so these haven't been activated. But if you go to do a future scenario for any year out to 2100, for the study area of Australia that I have loaded here, you can see all the GCMs that are available for you and RCMs. These are RCMs right here. And you can choose 1, 2, 3, you can choose all of them, and then that will run an ensemble of all those models. Now, you say, RCMs, where have those RCMs been acquired from? We work with the Cordex data, and I think this is really quite important that you understand that within SimCLIM, we now have dynamically downscaled data and statistically downscaled data. So there's the Cordex data SimCLIM packages, and we've got basically all the available patterns out there right now. We keep up to date on when new ones are released. So we have all the domains here, and as you'll see, we've got the Africa domain, which has 22 models. So when we're doing modeling for Nigeria, Botswana, or Ethiopia, we have the 40 regular GCM patterns that are statistically downscaled, and then 22 additional models. So you have 62 models to work with. This is quite important because the IPCC says in their guidelines that we should be using as many models as possible in ensembles. In most cases, when you're doing this sort of analysis, you should be able to use as many models as possible. That opens up some statistical opportunities. You can look at 10 and 90th percentile, 25 and 75th. You'll see that when I go into more detail with these models. This is the domain for the Africa Cordex. We also have the Middle East, MENA, as well. So you even get more models if you're working in Ethiopia, Nigeria, and so on, Chad, because there's overlap with MENA. You can have those models as well. So you have well over 60 models. We have Central America. You see they're covered by 10 models with 7 variables. So this isn't only precipitation and min-max temperature, but solar radiation and relative humidity and wind. So all those data are there for these countries covered by this domain. We also have for South Asia, centered on India. Again, all that data is available within the SimCLIM system. South America, we're still waiting on more patterns to come out of South America, but we have the 2 that have been put up. So there's addition to the 40, we have 2 dynamically downscaled. And there's 4 South America. And we even have the Arctic domain that came out earlier this year. 7 new RCMs just for the Arctic, and again, 7 variables. And with East Asia, we have 6 for East Asia, again with overlap into South Asia. And also North America, which just came out a few months ago now, but they've only processed for 4 variables. We'll be watching to see if they add more in the future and be adding them into the SimCLIM system. And that covers Canada, most of it, just about all of Alaska, and a bit of the Arctic as well, and into Central America, and into the Caribbean. We have the most recent one is in our part of the world, Australia and New Zealand, Southwest Pacific, and Indonesia, up to Malaysia. This was just made available by CSIRO in the last couple of months, and we processed all that data as well. And then Europe, 18 models with 7 variables for Europe, with a good quality domain there, and again, all that data in SimCLIM. So that's quite important that you know where that data has come from. So that's all part of the spatial areas that we now have within SimCLIM. And you see those choices there. Select all, and we can move this up a little bit and say OK. With this window, you can choose the RCP, it's climate sensitivity. Again, this is the based on IPCC guidelines. You can choose various months, seasons, and so on. Click OK, and it'll generate your map for you. Then you can run future scenarios, ensembles, and so on. The choice is yours. Quite robust, and it's quite fast at going through all these models as well. So it's really quite a handy tool for doing this sort of spatial analysis. And as I'm going to show you in a moment, as it works through all those models, we do have 204 country study areas now, or various study areas. Some areas we've broken down to state level, like Australia, India, USA, Canada, state or provincial level. We can work to any resolution scale. We work globally, nationally, and down to state, provincial, and city level. We work in small island states as well. So we work in places like Kiribati, Marshall Islands. We're doing some work now in the Cook Islands with very small islands and such. So it's quite powerful in that regard, where we can work at all these different scales. That's taking a little longer with everybody on here to process, but there it is. There's a full ensemble of 46 patterns for Australia. And again, I wanted to show you here that there are many different areas that we've already created and you can work in. You see all the US, all the different states. These are just the ones I have loaded in my system. Punjab, Orissa, all the provinces of New Zealand we have here, Mexico, Madagascar, Laos. We even work on basins like the Mekong River, because we work with the Mekong River Commission, the Nile Basin, so on. Ethiopia is there, Chile, Chad, quite a few areas, all within the area box here. All right, so there's the scenario generator. That's one part of the tools here. This is a 2050 T-Max for Australia with 46 models. Now, I'm not going to run through all the tools, just the main ones. We do have a new mapping program we're working on here, and if you want to have a demo, we can share that with you. That's quite an interesting a new way of looking at mapping, more options for adding in shape files and so on, and some ways of building your legends and such. Another important tool is this one, which is your site-specific scenario generator. Now, to save time, I've already opened up one of these, the site-specific scenario generator. The site-specific scenario generator is very good at exposing very transparently what underlying GCMs and RCMs are doing, what their data is, and how they compare with each other, which is really quite an important thing to be able to understand when you're looking at uncertainty. So I preloaded one here because it could take a little while to go through all that and put all these windows up. I wanted to save some time. Basically, what you go through is choose your variable. So I've chosen precipitation already here. The GCMs that you want to have, again, choose 3, 4, 5, whatever you want, all of them, up to you. And then the months you want to analyze, again, you can do seasonally, 1 month at a time. And again, your RCPs. You apply that, the map will come out for the area you're looking at. You choose the area you want to look at. In this case, I've chosen Brisbane, in the Brisbane area of Australia. And you see in this part of Australia, and I've chosen this on purpose, in this part of Australia, we're looking at precipitation declining over the next 50, 60, 70 years, up to 2100, 80 years. And this is very important when we look at extreme event analysis. So it's very easy just to choose any area in here in the map, any lat long, and you can generate your outputs to that. And if you can chart it as I've done here, you can save it, you can export it to Excel, do all those sorts of things. Now, the other thing you can do, and I've already opened these windows, is you can look at the patterns. You can look at the underlying GCM data. This is very important to understand the variability across the models. When you're doing work, you want to know it's not a black box. Each GCM or RCM is doing, how it compares across each month, and whether it's the signal is drier or wetter, and you have more models showing that it's going to become drier, more models showing it's become wetter. You can compare all of that with this tool, the site-specific scenario generator. And you also get summary statistics at the bottom, where you get the median, the average, the low, and high percentile, all very handy for looking at the underlying data within the system and to understand, better understand what's happening with your data. And this is even strengthened even further by being able to chart this. So to visualize what's happening with your data. So you can look at the variability across all those models. It's much like the spaghetti diagrams they use on cyclone, hurricane, typhoon modeling paths looking forward. We get more confidence when things are bunched together. And we can see that in this part of Brisbane, we get a lot more agreement in the models in September, October, November, December than we get here in March, April, May, June, July. Although the median here will run pretty much through this area here. But at least you can understand how much variability there is within the models. And there is quite a bit. And this is not inherent to the way we process that data. This is inherent in the modeling groups that actually develop the GCMs, the raw GCM data. They all have slightly different ways of doing this. And this way you get to see it and get to be able to understand why there is uncertainty within the GCM, RCM data. And the other thing it shows is that RCM data and GCM data really isn't that much different. When you put it into a diagram like this, you see they're all in there together. There's not one that stands out as being different from the other. It's just more data. And we've written a fair bit about the RCM, GCM data. But we find this to be a very useful way of understanding the underlying data. And as I say, it's very transparent. Because it's very important that you understand where that data is coming from. So that's the site-specific scenario generator. Again, anywhere in the world, basically, you can go in, click on a latitude, longitude, and extract the precipitation, temperature, those sorts of things, and look at the future. Now, remember, we were looking at Brisbane, and we were showing that that part of southeast Queensland was getting drier over time. All right, I can close these now. I can go back to the other one. I'll just leave this because we're going to come back to that later. The other major tool here within the scenario mapping area is the sea level rise scenario generator. This is a generator that's been used in IPCC reporting. They've used our generator to generate outputs for the reports in IPCC reporting, CMAP4 and such. So they have relied on our software to do some of that work. It's very important that we know that we consider local vertical land movement within this program as well. And again, we have 28 models here of sea level rise. Again, you can choose your RCP. I'm not going to do anything with the locally observed trend right now. We apply that, and then a map will be generated, and then again, you can zoom in to anywhere around the planet, any coastline, and choose to do a sea level rise analysis. So if we zoom in a little bit, and we'll just go into Manila here, Manila Bay, and let me select that. Select tool on, select that long, and then we will load the data, and we'll chart that, and there you go. You see sea level rise with RCP 8.5 high scenario, high sensitivity, about 110 centimeters by the year 2100, 111. I know that in Manila Bay it's actually sinking a little bit land, so that it's more like 120 to 130. In the manual, it shows how you generate very quickly and easily that trend for vertical land movement. We have a web tool that allows you to use SONIL and PMSL data to very rapidly assess what the vertical land movement is in this area. Put the number in, run it again, and you got the potential sea level rise for anywhere, any coastline around the world, just like that. And you can export this data as well. You can copy it, save it, all those sorts of things. So it's a very robust sea level rise assessment tool. And this, again, is used very widely because it is quick and robust and includes vertical land movement. Not every place is sinking around the world. Some places are stable, some continental margins with large cratons and such are very stable. Australia is relatively stable. India is relatively stable. But There's some areas like the Gulf Coast in USA, Manila, some areas in the South Indian Ocean, such as sinking. And it's really quite profound what happens with sea level rise when you consider vertical land movement as well. So that's a very important tool. There is a batch mode here for doing scenario sets. So if you want to run multiple analyses, perhaps for the same place, but for a whole host of, and we're not going to populate this, for a whole host of variables, this is the place you go. You may want to run all 4 variables against the same place. Well, you need to ask it to do all that, and you may want to ask it to look at 5 different time slices as well. We're still adding people into the program, into the webinar here, and that's quite a handy tool when you're trying to do a lot of scenarios very quickly, and it generates them and puts them into a folder, and you can go back and look at all the results. And that's going to load very slowly, so we'll just leave that because there's a lot of data to put in there. So we'll leave that one cranking away. All right, the other important tool here for site data is your data browser. We need to know a lot about individual sites when we're doing extreme event analysis in particular. We also have a lot of data. For Australia, for example, we have bomb data preloaded, over 10,000 sites within the SimCLIM system. North America, for India, we have data for every country, from NCDC, from various sources that come preloaded in the system. You can, I can zoom in here a little bit so you can get a better feel for just how much data we're talking about here. In the case of Australia, zoom in a little bit. And you see just how many data sites there are, just in a little smidgen of northern Tasmania and down in Victoria here. There's just a lot of sites. And they all have different types of data. Some have just temperature data. Some have just precipitation data. It's a whole mix. It's some really rich records. In the case of Australia, from 1933 to 93, all different record lengths and such. And all this data has been prepared and put into the SimCLIM system for your particular area. As you see, once I loaded some data, then the tools become alive. You can calculate a long-term normal, aggregate data if it's daily into monthly, yearly, very easily to see what's happening across a long time span. You can sort it, look for extremes in here. You can do a running mean very quickly, and then you can go and search out particular dates if you know an extreme event occurred in a certain period. So this is quite a very powerful tool, and you can also run scenarios against this data so you can see how that can be perturbed for future based on the historical. All right, based on that time series data, the historical time series data, is one of the most important tools within SimCLIM, which is the extreme event analysis tool. Now, remember, I was looking at, we were looking at Brisbane for its annual precipitation declining. Well, let's do a little analysis of extreme events and extreme rainfall. And let's pull up Brisbane Airport as a particular site to examine. Now we're going to look at extreme rainfall based on a daily GCM. So we have 30 GCMs with daily data just for doing this sort of daily extreme rainfall analysis. Again, you can do it by month, season, yearly. We'll do all. And again, we'll do a baseline here first, and we'll run that. And very quickly, you get an analysis of the extreme, value 4. What did I choose? Temperature. Whoop. Let me go back. I want to do precipitation in this case. That was temperature, 39 degrees. It gets warm and busy. And again, there we go. Now we've got precipitation. So let's standardize this a bit. 1 in a 100-year event, 303 millimeters of rain. A bad day in Brisbane when you get that sort of rain. But let's look at what might happen in 2070, for example. We'll choose the daily GCM GEV value changes. And let's look at 2070. We'll do an ensemble of all those patterns. We could look at the 10th and 90th percentiles and look at the worst case, or the less than worst case, obviously, if we do the 10th percentile. But you can do this sort of statistical analysis very quickly here. And we'll do a median sensitivity, and we'll run that. And let's see what happens. Remember, we were showing Brisbane as drying over the longer term in terms of annual precipitation. But what's happened here? Let me downsize this window a little bit and look at here. If we go to a 100-year event, that 100-year event has gone from 303 millimeters in 2070 to 344. This is something that's very important for certain areas of the world where, in fact, they're getting drier, but their extremes are becoming more extreme. And we're seeing more examples of this with urban flooding and all kinds of examples around the world. And we discovered this doing a project in Southeast Queensland about 8 years ago, actually. We developed these new methods to overcome this situation. And CMAP5 data, with all its daily good and extension of models. We had it in CMAP4, but there are a lot more models in CMAP5. We're able to do this sort of daily analysis. It's quite robust for rainfall. So we're quite happy with this sort of tool. It's very quick and easy to run. And so table, and you can look at the return period for a 2-year event, a 5-year event, a 10-year, 20, 100. Say you want to know a 200-year event, just put 200 years in, 300-year event, and you can look at that and the values that come in. It's very quick to use. You can look at the difference between baseline and the GCMs. This is all copy and exportable as well. So you can then put it into Excel and do various things with it. It's really quite a powerful tool looking at the extreme events. Again, it's not just temperature. We can look at heat waves as well. It's a very powerful tool for doing that. You can look at Tmax. You can look at the number of days, say 4 days over 35 degrees Celsius. What's the probability of that going forward? So it's a very quick and efficient way of looking at how heat waves may evolve over time with the GCM data. So this is quite a useful tool used by many to do that sort of heat analysis as well. And there are other things you can do with this, but we don't have time to go through all that now. But it's quite a powerful little toolkit. All right, the other things you can do, there are impact models built into the system. There's a water balance model. There is a coastal erosion model based on the modified Bruin rule. And we also have a degree day model and rainwater collection model. Now, somebody's asked about it's possible to look at forest fire projections in Australia. We can do that. We don't do that within SimCLIM. You can do that with, we can look at that with SimCLIM for ArcGIS. We have another version with SimCLIM for ArcGIS, and we do create raster files for fire risk across Australia. So that's possible to be done, but not directly within SimCLIM at the moment. That's the fire risk models that we use are a little bit more complicated than something that can be done within this platform. But they can be done, and we have done them. And that was somebody who was asking about that on the chat. So that is possible, but not within the SimCLIM system as it is here. And the rainwater collection model is quite handy for looking at roof sizes, water tank sizes, usage, and also climate proofing those. So looking out into the future of number of consecutive dry days and how much, how big a tank needs to be for storage water and how often you'd like you can tolerate that going dry. So all these models are built into the system. We also have interfaces for DHI, so you can introduce DFSO files to SimCLIM. SimCLIM can perturb those files with different RCPs, time slices. They get exported out of the system, and then you import those into your Mic 11 and so on, and then you can run DHI software with consideration of climate change. Same with DASIT, Decision Support System for Agri-Technology Transfer. This is for one of the top agricultural models that's out there based on series models of the past. We've been at it for a long time. We work very closely with Jared Ogenboom and the team at DASIT. And again, you introduce the weather files from DASIT into the system, perturb them for future climate of your choice, and then they're exported and then introduced to a DASIT program to run that program with consideration of climate change. Same issues with the SWOT perturbation tool. So you SWOT model or hydrological basins and such, you can export that, import that data into the SimCLIM system, perturb it, future climate of your choice and time slice, and then export that data and run your SWOT model with consideration of climate change. Those can be very powerful tools. Now, the rest of what we have here are just management tools. So Site Data Manager, you can export site data, you can import site data, you can manage the site data. There's just so much you can do within the Site Data Manager. So I have 19,000 daily sites within my system here, 181 hourly sites. All of these you can import, export, share across SimCLIM platforms. A very robust tool and easy to move data around within the Site Data Manager. And easy to import. If you need data for a particular area, we can send you a data package and it unzips and just puts that data into your system with only a few clicks. It's really quite handy. And the other quite handy tool is the Manage Areas tool. Again, this allows you to move things around in your tree, add new areas, delete areas, see what's actually in those patterns, see what's there in terms of the GCMs, RCMs. You can understand that's the global, the details, the resolution, half a degree in this case for the global, and what variables are available there. As you see, we got a full suite for global here. All this, again, you can browse and go and look at it in your data folder, move things around, import, delete, save things. It's quite a powerful tool. And then we get into specifics of opening image files, managing your palettes, changing colors. You can print things, save things. These are all tools here for, and I'll just very quickly do a baseline map here so we bring those to life. We're running out of time here. And you'll see once this map is generated, all these tools here come to life because these are tools you use for display options. You can change your legend to any sort of scale you want to have there, and number of options there. Let's reduce to 3. Or if it's to 10, it just changes those. You can change the colors of all these things. Lots of options here. You can sync images. When you have multiple images, you need to get all the legends together to match each other to see change. You can link those. You can reclass the image. Again, there's the palette. You can generate new areas by zooming into an area. You could cut that out and create your own new area based on the GCM and RCM data that's there. And then for high-end users, you can use your calculator and do some on-the-fly programming, basically, to analyze the images. When you have more than one image open, you can start to analyze.